This video will go through the review sheet for you guys. So just going through some of the transformations. So here we've got a plus 32 on the inside, which means we are going to the left 32. Here that negative is on the inside, which means it's a horizontal reflection. Another way you might see that, this is a reflection over, since it's horizontal, that'd be the y-axis. 4 on the outside means it's a vertical stretch times 4. Here we got two moves. You got the -2 on the inside, which means we're going to the right 2, and that +8 on the outside means we're going up 8. Here that -7 means we're going down 7. That negative on the outside here, remember we want to make sure that they're in order. And remember, anytime there's multiple moves, the translation or the slide is always last. So here the negative on the outside means we have a vertical reflection followed by a move that sends us up 6. That 1/3 on the outside, so that's a vertical compression by 1/3. Here we got three things happening. First, you got the negative right there, which means we have a vertical reflection. If you want to think about this again, this is a reflection over the x-axis. And then we have that +4, which means we're going to the left 4. And that +9, which means we're going up 9. Now let's go the other way. Reflect over the y-axis. So the y-axis would mean that we're flipping horizontally. So that means that the negative is on the inside, and we're going down 2. Translate to the left 9. So to send it to the left 9, we need to do +9, and then down 2, -2. So stretch horizontally by 5. So since it's horizontal, it's going to be on the inside. Remember, inside's always backwards. So instead of it being stretched by 5, we actually have to do the 1/5 x, and then to flip across the x-axis, this would be actually a vertical flip. So I'm going to sneak a negative out in front of the F, kind of right next to my 11. Stretch vertically by 7, so a vertical stretch, I mean that 7's on the outside. Then we're going to go up 7, which means the +7 is also on the outside. Reflect across the x-axis. So again, this is a vertical move. We need to do negative f of x, but we need to go up 12 into the left 13. So the left 13 would be +13 on the inside, and then +12 on the outside. Reflect across the y-axis. So this would be a horizontal move. Right? Again, the y-axis is up and down, so if we flip across it, right, this is a horizontal flip. Just a quick reminder. So if we're going to do a horizontal flip, that means it needs to be on the inside. So my negative is on the inside. Shrink vertically by half. Or a vertical compression would mean that the 1/2 is on the outside. Translate to the right 8. So that would be x minus 8. So we'll start looking at some problems. So let's say we have the point 4, -15. What happens when we reflect across the line y equals x? This is, remember we called this the inverse? And most of you guys probably recall this. This is pretty easy. Really, all we need to do is just switch 4 and 15. So my new point is -15, 4. Right? What operation do you perform first for this? So we have there's a vertical stretch. You're going to shift it to the right, and you're going to shift it up. Remember, translation is always last. Translation is last. So anytime you do a slide, it's always last, which means which one happens first would be the vertical stretch by 4. All right, number 20, which operation do you perform last? So you have a negative here. You got a vertical reflection. You got a vertical stretch. You have a horizontal reflection. But remember, translation is always last, which means we have to do that +18 last. So the last thing we do is go up 18. So let's look to the right, the domain and range. So I'm going to throw a few characteristic points on here for you guys so we can see exactly what we're looking at. So the domain, right, goes all the way from here up to there. So we're looking at a domain from -1, 2, 3, 4, 5, all the way up to 2. Keep in mind those values are included, so use square brackets. The range, remember, is up and down, right? So this is the range, and this is the domain. So the range goes all the way from -3 up to 1. And again, those values are included, so we'll do brackets. Is this a function? Yes. It passes the vertical line test. All right, the next set of problems. So if the original domain, that has to do with the x's, is from -3 to 8, and we shift it to the right 7. So that means we're going plus 7 with the x's, right? The new domain, so in other words, we do -3 plus 7, and we have to do 8 plus 7. So the new domain is from 4 to 15. The range, remember the range is y. We're going to shift it down. So in other words, we're going to take all of our y's, we're going to go -12 with the range, or the y's, if you will. So we do 3 minus 12, and 17 minus 12. So our new range, 3 minus 12 is -9. 17 minus 12 is 5. So there's my new range. So here we go, the range of a function, right? The y's go from 6 to 2. That function shifts to the right 5. Well, right would be a plus 5 with the x's. Well, this is a little bit tricky because we're looking for a range. So the new range actually isn't changed, right? They gave us the original range of 6, 2. These are y's. They asked us to add 5 to all the x's, so the new range actually stays right where it started. All right, let's look at some of these with some of the parent functions. So what happens when we multiply by 3 on the inside? Well, it's inside, so it's a horizontal move. And since it's a multiplying situation, there's actually a horizontal compression by 3. All right, here that 5 is on the inside, which means it's a horizontal move, and plus means we're actually going to go left 5. All right, write the function square root of x after reflection over the x-axis. So let's think about that for just a minute. Right, the x-axis is this one right here. So if we flip over it, that's really saying a vertical reflection. And since it's vertical, it needs to go outside. So we have f of x. So we got the negative square root of x, and the up 3 is outside. So plus 3 is on the outside of the square root as well. Write the function x squared after a translation of down 16. That's a vertical move, which means the x squared comes, and then 16 comes afterwards. So we just keep the 16 outside of the function. Next up, so we'll go ahead and grab some characteristic points for this function. So we have the point -3, 0, the point -2, -2, the point 0, 2, the point 1, 2, the point 2, 0, and the point 3, 1. So what is the domain? Again, domain, everything left to right. So the domain will be from -3 up to 3, and it's continuous, right? There's never a break. And then the range, keeping in mind the range is up and down. So the range here goes all the way from -2 up to +2. And then finally, is it a function? And yes. Again, it passes the vertical line test. On to page 3. So let's take that function and we're going to perform the transformation negative f of x. So in other words, this is a vertical reflection. Now since it's vertical, we'll change the y's. So in other words, let me remind us what our original points were. Right, if we go and put points here, A, B, C, D, E, and F. So the original point A was -3, 0. I'm just going to draw these in here real quick. B, C, D. So right, there's A. So the original B was -2, -2. The original C was 0, 2. The original D was 1, 2. The original E was 2, 0. And then the original F was 3, 1. Right? And we're going to flip it over the in a vertical direction. So in other words, all the y's are going to flip. So one thing we can go ahead and start thinking about, into the chart, I'll use a different color here, into the chart, the x's stay the same, remember. If we go ahead and do the vertical reflection, right, A prime is here, B prime, we're flipping vertically. So since C was 2 above, C prime will be 2 below. D is 2 above, so D prime will be 2 below. E is right on the line. And then F is 1 above, so F prime be 1 below. And then if we go ahead and connect these, what we should see, if we go ahead and get all the new points, clean this up just a little bit. If we go get all the new points, notice the x's don't change, but all of the y's all of a sudden, right? A prime's at negative 3, 0. B prime's at negative 2, positive 2. C prime, it went from 0, 2 to 0, negative 2. D prime, which is right here, it went from 1, 2 to 1, negative 2. E went from 2, 0, it stayed put, 2, 0. And then F went from 3, 1, and it changed to 3, negative 1. So my new domain, well, the domain actually remains the exact same. It stays from negative 3 up to positive 3. And the range, interestingly enough, it didn't change. It went from negative 2 to 2. So we're looking at the red function for the new one. All right. So let's say that we wanted to take this and we wanted to do x plus 1. So in other words, we're going to shift it to the left 1. So take all of our points. That's going to shift here, here. That'll shift. That'll shift. That'll shift. So my new points, excuse me. Okay. So if we notice, the y's actually didn't change, but my new a is negative 4, 0. My new b is now negative 3, negative 2. My new c is negative 1, 2. My new d is 0, 2. My new e prime is now 1, 0. And my new f prime, right there, is actually now 2, 1. What actually changed? Well, the domain did. We're now starting at negative 4 going up to 2. And since we only slid back, we didn't slide up or down, which means that my range is still the exact same thing at negative 2 to 2. Right? And then finally, let's get the inverse of f of x. So in other words, this is probably one, it's a lot easier probably just to go and get the points, right? Remember, if we're doing inverse, that's y equals x. So we just switch x and y. So the original a, if we go back up to the top, the original a was negative 3, 0, which means a prime is now 0, negative 3. Right? The original b is at negative 2, negative 2. Right? There's the original b. So we switch them, it actually stays the exact same at negative 2, negative 2. The original c was 0, 2, which means c prime is now 2, 0. The original d, if you go back up to the top, right, and again, I'm just pulling these originals from that list right here. So the original d was 1, 2, which means my new d is now 2, 1. The original e, if you look back at the top, with the original e was 2, 0, which means now I'm at 0, 2. And the original f was 3, 1, which means now I'm at 1, 3. So find the coordinates of that inverse. So now all of a sudden, let me graph those. So 0, negative 3. There's a prime. B is negative 2, negative 2. There's b prime. C is now 2, 0. C prime. D prime is 2, 1. B prime. E prime is 0, 2. And then there's F prime. So we got to think for a minute. Here we go. Up. Down to E, back to F. So right, we're looking at the black function. So my new domain here goes from negative 2 up to positive 2. My new range, right, all the way from down here at negative 3 to positive 3. And is this new function, or is this new drawing a function? Well, there's a couple ways to look at it. Here you can see some repeating x's, both the 2 and the 0 repeat. Or look at the graph. There's two ways to look at it. X's repeat, and it fails the vertical line test. So this is not, the inverse is not a function.